Today, I'm excited to talk about streptomycin sulfate, a groundbreaking antibiotic that not only changed the history of medicine but continues to play a vital role today. My name is Jikang Cheng, and here's 5 points we will present. So, first, streptomycin sulfate is a sulfate salt form of streptomycin which appears as a white to off-white crystalline powder and it dissolves easily in water. It was discovered in 1943 by American microbiologist Selman Waksman. Most notably, streptomycin was the first antibiotic effective against tuberculosis, dramatically improving treatment outcomes and saving countless lives. Streptomycin sulfate appears as a white to off-white crystalline powder and has a high molecular weight of around 1,457.4 grams per mole. It is dissolved easily in water, though it is soluble in alcohol and not soluble in organic solvents like ether. Its mechanism of action involves binding to bacteria such as ribosome spunate, blocking protein synthesis and causing bacterial cell death. It is best stored in cool, dry, sealed conditions to maintain stability. Streptomycin sulfate is mainly used in medical research such as anti-tuberculosis treatment, endocarditis, and other bacterial infections. In terms of viral applications, it can treat respiratory and digestive tract infections in animals and is mainly used in aquaculture. Finally, in terms of experimental research, transgenic cells with streptomycin resistance genes were screened, which played a significant role in combating plague. So, several leading pharmaceutical companies contribute to the global supplies of streptomycin sulfate, like Pfizer Global Pharmaceuticals in the US. As one of the pioneers in antibiotic production, Pfizer was instrumental in bringing streptomycin to industrial scale in 1940s. And the Shandong Lukang Lukang Pharmaceutical stands as one of the largest suppliers of pure streptomycin sulfate, and the Xelia Pharmaceuticals in Denmark. Xelia specialized in high purity anti-infectives for critical care.
Will introduce you about the physiologic characteristic and the product synthesis. Streptomyces has a complex mycelial structure, including substrate mycelia and aerial mycelia. The aerial mycelia grows from the substrate mycelia, usually with a branched structure, and eventually forms spore chains. Streptomycelium are chemoheterotrophic microorganisms. Streptomyces usually only one carbon source, one inorganic nitrogen source, and a small amount of inorganic source. The metabolic process of streptomyces is divided into primary metabolism and secondary metabolism. Primary metabolism is a basic metabolic process that maintains cell growth and reproduction. It produces biological macromolecules such as amino acids, nucleotides, and fatty acids. Secondary metabolism mainly produces bioactive secondary metabolites such as antibiotics and pigments. The growth cycle of streptomyces includes 3 stages: mycelia growth, aerial mycelia formation, and spore production. At first it is a spore. After germination, it grows into germinating spore. During the mycelia growth stage, streptomyces grows rapidly by absorbing nutrients. As nutrients are consumed, aerial mycelia begins to form and gradually differentiates into spore chains. The synthesis of secondary metabolites usually starts in the middle and the late stages of growth. This is a flowchart of streptomycin production process. For the strain preparation, it starts with the strain, which goes through slime spore culture, flask seed culture, and seed time culture to obtain the seed for fermentation. For the air treatment, air undergoes coarse filtration. It's compressed by an air compressor, goes through two-stage cooling and gas-liquid separation, and finally filtration sterilization to provide sterile air for fermentation. For the raw material processing, raw materials are pre-treated, hydrolyzed, filtered, made into an alcohol solution, and sterilized before being used in fermentation. After that, the seed from seed tank culture, along with treated air and raw materials, enters the fermentation stage, resulting in fermentation brews. The fermentation brews is pre-treated. After that, it is into primary purification. The purification involves cation exchange elutions, Gibbs reaction, desalting, and neutralization to get streptomycin purified liquid. The last part is refining. The purified liquid is decolorized with medical activated carbon, concentrated by vacuum evaporation, sterilized by filtration, and sprayed dry to obtain the final product.
My name is Liu Jingqu. Now I will outline the upstream fermentation process for Streptomyces griseus, covering strain preparation, seed expansion, and fermentation. First, we begin by isolating robust single colonies from soil or frozen tubes, using a two-step slant culture process. This ensures strain purity before seed cultivation. Next, we conduct shake flask seed culture. Colonies from slants are transferred into flasks with a medium containing soybean meal, glucose, ammonium sulfate, and calcium carbonate. These seeds can be directly used to inoculate seed tanks or further expanded via subflask. In the seed cultivation process, we aim to increase seed quantity to enhance fermentation efficiency. In the primary seed tank, we inoculate with strains using a medium that includes glucose, soybean meal, and ammonium sulfate. Next, we transfer the culture to the secondary seed tank, keeping similar conditions with slight adjustments. Then, in the tertiary seed tank, we continue to expand the culture in a larger tank, making further adjustments to aeration and stirring. Finally, the seed culture is inoculated into the fermenter. Stereo air and agitation maintain optimal oxygen levels for production. The media for primary and secondary seed tanks undergo batch sterilization, while the tertiary seed tank and fermentation media are continuously sterilized. This sets the stage for downstream processing, which my groupmate will talk about the detail.
My name is Wang Chenxi, and my part is about the separation and purification. First, dilute the fermentation broth with soft water and then acidify it with oxalic acid to adjust the pH value up to approximately 3.0. Next, heat the diluted and acidified liquid to a temperature range of 75 to 8 degrees to carry out the separation. Hard separation or plate and frame filtration technology can effectively remove insoluble mycelium, acid proteins, calcium and magnesium ions from it, and impurities such as residues of the culture medium to ensure the purity of the liquid and the smooth progress of subsequent processing. Like this video introduce the future separation technology. After the treated liquid is cooled to below 15 degrees, it forms satisfactory ions through the neutralization effect of the sodium hydrogenation. Exchange the extra topsoil clear its solution in accordance with the process standard. In the pre-treated stroke solution, streptozan exists in the aqueous solution in the form of the treated cations. For further to improve the purity and concentration of streptozan, certain type weekly exit cation extract resin 1100 microporous D152 resin is adopted. In addition, by taking advantage of the selective adsorption characteristics of ion exchange resins, most inorganic ions and pigments in the original solution can be removed. Impurities such as elements, proteins, and visible solids have laid the foundation for subsequent purification and extraction of the streptozan. And this video introduced the cation exchange resin technology. To further enhance the purity of the streptozan extract was subsequently passed through the microporous primary amine adsorption resin when combined with the Schiff reaction. D303 effectively removes substances such as dihydrostreptozan, streptozan guidance, and streptozan amine that do not contain aldehyde groups. The purified liquid will first undergo a preliminary purification treatment with mechanical activity carbon acetate amide aimed at effective absorption it. Pigments and bacteria indocent then through low temperature vacuum evaporation technology. The temperature is controlled below the 45-degree concentration, which carried out under certain conditions, will significantly increase the concentration of streptozan to approximately 45%. To ensure the quality of the final product, it requires the reintroduction of medical activity carbon for decoloration and purification treatment. And this video introduced the decoloration and purification treatment. This step aims to ensure the bacteria that contains impurities such as endoxins and purifiers meet the industry standards. Through the above-mentioned multiple refining processes, the final quality is achieved outstanding streptozan finished concentrate.
I'm He, and I'm going to talk about the third part, quality control. So for in-process quality control, the key to quality control of the slope culture of the spores lies in ensuring that the colonies are evenly distributed and have a moderate density and are white in color and full in shape. Next, the quality of the strain is verified through shake flask test, and a series of detailed indicators were adopted for quality assessment. And these indicators cover the detection of fermentation efficiency, color of the seed liquid, and aseptic status. By strictly monitoring these indicators, the stability and efficiency of the streptomycin production process have been ensured. The key components of the culture medium include soybean cacao powder, glucose, ammonium sulfate. The precise preparation of those components plays a decisive role in ensuring the cultural effect. Sterilization of the culture medium also plays an important role in quality control, and we adopted 3 sterilization methods like batch, continuous, filtration, sterilization, and different methods were used for different stages of the culture medium. So during the fermentation process, we also have specific requirements for indicators such as the fermentation level, product titer, contamination rate to ensure that the final quality of the finished product is up to standard. And during the separation and purification process, the fermentation broth was pre-treated by controlling pH and temperature to remove impurities. And many requirements on indicators were also made during the extraction stage, and like total extraction yield should be 70%, and refined yield should be 90%, so that we can better ensure the quality of the finished product. For final product quality control, and we have used many methods for testing to ensure the quality of the finished products is up to standard. For example, we need to ensure that the streptomycin residue is less than or equal to 0.1%. Okay, thank you for listening.